Hello and welcome to Controllers Tech. This is the fifth video in the STM32 TouchGFX series, and today we will see how to send the UART data to the UI. I have already covered how we can sample from a GUI task, from the interrupt, and from another task, and display the data on the UI. This video is kind of an extension to what we did so far. So far the data we sent consists of only numbers, and it was easier to send them in a queue. But the data received from the UART will be a set of characters, words, or sentences, so using a simple queue won't be possible. I have covered the queues in my RTOS video series, where I covered the simple queue, and the structured queue. Today we will use this structured queue to send the data to the GUI. We will see them in a while. Let's start the TouchGFX and create a new project. I am using my usual F750 discovery board. Give some name to the project and click Create. First of all we will add a background image to the UI. I just want to display the UART data, so let's add a text area to this screen. Make sure you uncheck the auto size, and now adjust the text area as per your requirement. The data is going to be received from the UART, so we need to add a wildcard here. I am going to receive a maximum of 256 characters at once, so set the wildcard buffer at 1 higher than that. Now go to Text, Typographies. Here I am making the font a little bit bold. Now define the wildcard range. 20 to 7E hexa covers all the useful ASCII characters. This is it for the GUI setup. Let's generate the code now. Go to File, Project Folder, CubeIDE, and open the project in CubeIDE. Let's make some changes in the IOC file first. The UART1 is already enabled. The pins used are PA9 and PB7. Here in the schematics, you can see the pin PA9 is the virtual COM-TX pin, and PB7 is the RX pin. Since it's already selected, I don't need to enable the UART. So I am just going to enable the interrupt for the UART1. Now we need to add a queue to transfer the data to the GUI task. So go to FreeRTOS, Tasks and Queues, and add a queue. Since data from the UART is not going to come at a very high rate, 2 elements are enough. I am setting the element size as integer for now, but we will change it later in the code. This is it for the CubeMX. Click Save to generate the project. Let's build the code once. Alright, let's create an array to store the data received from the UART. Now when the default task runs for the first time, we will call the function receive_to_idle in the interrupt mode. It is necessary that you call this function after the kernel has started, as we will be using the queue-related functions in the interrupt handler. Receive_to_idle will receive the UART data until an idle line arrives, and when it does, it triggers an interrupt. The interrupt will call the callback function, RX event callback. Before we go ahead and write the callback, let's define our structure for the queue. I am defining it in the main header file, so that it can be linked to the TouchGFX files also. The structure will have 2 members, an integer variable to store the size of the data, and a character array to contain the data itself. Now in the main file, define a pointer to the UART data structure. Let's write the callback function now. Here the size variable is the size of the data we received from the UART. Let's write a terminating character to represent the end of the data. Now we will send the data to the queue. OS message get space returns the space available in the queue. We will only send the data if there is some space in the queue. First, copy the data stored in the rxData variable to our pointer to the structure. Since there is one additional byte, the size will be size plus 1. Now update the size member of the structure. Now send the structure using the OS message put function. The message pointer will be the address of the pointer we created. I am keeping the priority and timeout to 0. This means the function will only send the data to the queue if it has some space in it. Since the hold disables the interrupt after a single trigger, call the same function to reinitialize it. There is one more step left in the main file. The UART queue we created using the CubeMX still has integer size as the size of each element. So update it to the size of the structure. Looks like a spelling mistake here. Also, we need to include the string header file for string copy function. Let me typecast this to character pointer 2. So we have successfully sent the data to the queue. Now we need to receive it. The data will be received in the model tick function, so let's open the model source file. We will start with the header inclusion first. Include the main.h and cmsys2.h. Now we need to define the UART queue. Let's also define a new pointer to the UART data struct. It will be used to receive the data from the queue. Now in the model header file, define an array where the received data will be stored. Alright, let's write the tick function to receive the data. OS message get count returns the number of messages in the queue. If there is some message, we will receive it using the function OS message get. The message pointer will be the address of the pointer to the UART data structure. If the message is received successfully, the function returns OS OK. Here we will again copy the data from the structure to the array we created. And finally the model listener will call the function UART data in the presenter. The pointer to the array will be passed as the parameter to this function. This function is not defined yet, so we will first define it in the model listener header file. And then define it in the presenter header file. Now in the presenter source file, the same function will be called in the view. So define the function in the view header file, and we will finally write it in the view source file. Here we will use the string copy function, as the UART data contains only characters, and we can directly display it on the UI. So we will copy the data from the parameter to the text area buffer. And finally invalidate the text area, so for the changes to take effect. If you want to enable the word wrap, you need to add one more line here. We will set the wide text action, and we will set it to word wrap. So this is it. Let's build the code now. I forgot to close this definition here. Also we need to include the C string for the string copy function. The code builds fine, so let's flash it to the board. I am using the Hercules serial monitor to send the data via the UART. You can see the data is displaying just fine. Let's send some big data to check the word wrap. It is working fine too. Let me send a big paragraph now. Since the total characters are more than 256, the data was received in two parts, and you can see the second half of it. Let me delete a few characters. Now it displays fine. So you saw how we received the data from the UART and then sent it to the GUI task using the structured queue. This is it for this video. I hope you understood how to display the UART data on the UI. I will continue with the TouchGFX series, and will cover some more elements in upcoming videos. You can download the code from the link in the description. Leave comments in case of any doubt. Keep watching, and have a nice day ahead.